Hello learner, I am Dr. Purnima Tiwari, Assistant Professor of Mathematics, Department of Science, the Bhopal School of Social Sciences. This is first video on the topic double integrals. To understand this topic, you must familiar with definite integral for function of one variable. That is, with the integral a to b f of x dx. How we find this integral and various properties of definite as well as indefinite integrals. This concept of definite integral of one variable can be extended to a function with more than one variable, and such integrals are referred as multiple integrals. In this video lecture series, we will discuss about double integrals, that is integral with function of two variables, and triple integrals, that is integrals with function of three variables. This double integral is denoted by double integration over a f of xy dx dy, and triple integral is denoted by integration over v f of x, y, z, and integration is with respect to x, y, and z. Let us start with the concept of double integrals. Double integral is a way to integrate over two-dimensional area. It is used to calculate area of a region, volume under a surface, and average value of a function of two variables over a rectangular region. Now, one important remark: if this region A is a rectangular bounded by x equal to A, x equal to B, y is equal to C, and y is equal to D, then order of integration does not matter. It means this integral, this double integral is integral a to b, then integral c to d, f of xy dy and dx, and this integral is same as integral c to d, then integral a to b, f of xy dx, and then dy. Now we'll solve some example where we do double integration over a rectangle. That is, limits are constants and order of integration does not matter. First example is we have to calculate this double integral for the limit 0 to 1 and 0 to 2 x plus y dx dy. Now to this integral, we can write integral 0 to 1. First, we'll integrate for this limit 0 to 2 for this function x plus y, first with respect to x and then with respect to y. Now, when we integrate this x with respect to x, we get x square by 2. This limit as it is. Integration of x is x square by 2. Integration of y with respect to x is yx. Limits are 0 to 2 and then we'll integrate with respect to y. Now we'll apply upper limit and lower limit. So we'll get this integral 0 to 1. When we apply upper limit, we'll get 2 square by 2, that is 2. y as it is. We'll apply upper limit for x, so we'll get 2y. And when we apply lower limit, this value will be 0. It means now we have to integrate this quantity with respect to y. Now we have to integrate this quantity, integral 0 to 1, 2 plus 2y dy. When we integrate this 2 with respect to y, we get 2y plus sign. When we integrate this y with respect to y, we get y square by 2. So, on solving, we will get y square. And the limits of integration are 0 to 1. When we apply upper limit, we will get 2 into 1 plus 1 square. And when we apply lower limit, value will be 0. It means value of this integral 0 to 1, 0 to 2, x plus y dx dy is 2 plus 1, that is 3, and it's our answer. In next example, we will solve this integral 1 to a, 1 to b, 1 upon xy dx dy. Now we can write this integral as integral 1 to a, then integral 1 to b, 1 upon xy dx dy. First, we will integrate with respect to x and then we'll integrate with respect to y. Now, this first integration will as it is. When we integrate 1 upon xy with respect to x, this term 1 by y will deal like a constant. So, we'll write it as it is. Now, when we integrate 1 by x with respect to x, we'll get log x. Limits for this integration are from 1 to b and the next integration is with respect to y. Now, when we apply limits, the value will be this limit as it is, 1 by y as it is. When we apply limit, we'll get log b minus log 1. And value of log 1 is 0. It means this integral is integral 1 to a, 1 upon y log b dy. Now, this term log b is a constant. So, we'll integrate 1 by y and integration of 1 by y with respect to y is log y. So, this log b is constant, we'll write as it is. Integration of 1 by y is log y and the limits for integration are from 1 to a. Now, when we apply limit, we'll get log a minus log 1. Again, value of log 1 is 0. It means value of this integral is log a multiplied with log b. That's our answer. Now, we'll solve one more example. We have to find value of this double integral for the limit 0 to 1. And the function is 1 by square root of 1 minus x square, square root of 1 minus y square dx dy. Now, as per rule, we can write this integral as 0 to 1. First, we will integrate this function with respect to x, that is 1 by square root of 1 minus x square, square root of 1 minus y square. First integration with respect to x and then we'll integrate with respect to y. Now when we are doing integration with respect to x, this term 1 by square root of 1 minus y square will deal like a constant. So to this integral we can write 0 to 1, 1 by square root of 1 minus y square, integration of 1 upon square root of 1 minus x square with respect to x is sine inverse x. Limits of integration are from 0 to 1 and then we'll integrate with respect to y. Now when we apply limit, this value will be 0 to 1, this term as it is, square root of 1 minus y square. First we'll apply upper limit, that is we'll get sine inverse 1, and then we'll apply lower limit, we'll get sine inverse 0, and this dy as it is. Now we know that the value of sine inverse 1 is pi by 2 and sine inverse 0 is 0. So when we substitute these values, we'll get integral 0 to 1, 1 by square root of 1 minus y square pi by 2 dy. Now this pi by 2 is constant. We'll integrate this term 1 by square root of 1 minus y square with respect to y. So again we'll get sine inverse y and the limits are 0 to 1. When we substitute limit, we'll get pi by 2 multiplied with sine inverse 1 minus sine inverse 0. Again we'll substitute these values. Sine inverse 1 is pi by 2 and sine inverse 0 is 0. So we'll have one more pi by 2. So this pi by 2 multiplied with pi by 2, that is value of this integral is pi square by 4. That's our answer. You may solve some more examples for better understanding of this topic, double integral. We'll continue with this topic in next video. Thank you so much.